Hi everybody, this is Ms. Duncan-Taylor and this is my kitchen. Welcome to Kitchen Biology. And what I want to do today is I want to show you about carbohydrates. Now you've already seen a few videos about carbohydrates, but I want to show you about if we were in the classroom, these are some of the things we would do in the classroom. So I want to start off by showing you about monosaccharides, okay? So these are some examples of monosaccharides, single sugar molecules. And I want you to remember that single sugar molecules have one water molecule for every carbon, and that's why they're in liquid form, like honey or molasses. And then we go to the next group, the disaccharides. These are two sugar molecules, too sweet. So you take a mono plus a mono, stick them together, it spits out a water molecule, and you end up with what's called a disaccharide. Now take a look. Okay, look up here. Monosaccharides are liquid. Disaccharides now have some of the water molecules removed. So they're drier molecules. Okay? Now let's go to the next group. The polysaccharides. Poly means many sugars. So you take a mono plus a mono plus a mono plus a mono plus a mono, and you keep on going and going and going. And every place you stick a monosaccharide together, it spits out a water. So all these water molecules are coming out. The molecule gets bigger and bigger and bigger, but it also gets drier and drier and drier. Like take a look at flour, for example, right? Flour, super dry, and it'll last a really long time. That's why these, like oats and grains like rice and nuts and potatoes, they store for a really long time because they have so much of their water removed, okay? The next group is a different kind of saccharides, and these are called the polysaccharides, the cellulose or the structural polysaccharides. Now think about this in terms of like being right-handed or left-handed. These are the molecules that are your non-dominant hand. They're there for support and help, and that's what the structural cellulose does. All right, and here's the kinds that we can eat. We eat them, but we don't really digest them. If we were termites, we would have the right enzymes for digesting them, but we don't. We eat them because they're the cell wall supports and we're getting other nutrients out of the food, but we can't really digest it. This is another kind of cellulose like wood fibers, and we turn it into things like cardboard or like cotton, whether it's cotton balls or cotton fibers, paper, all kinds of fabric, Kleenex even. All of this is also a cellulose. But I want to show you something. These celluloses are also the support here. So you're getting the edible kind of polysaccharide and the cellulose polysaccharide. And then over here, the same thing. Because these are cell walls on the plants, you're getting cellulose here, but you're getting a lot of monosaccharides. So you're actually getting multiples at once. You're getting multiple kinds of saccharides. Now you might remember in your freshman year, you did a sports drink thing, and you were looking at electrolytes and what's in a sports drink. Well, I want to do something with you here. You might remember the chemical Benedicts reagent. And Benedicts reagent is used as a sugar indicator. So what I've got here is I've got water, which we know is not a sugar because it doesn't even have carbon in it. And here is a monosaccharide, a known monosaccharide. And so we're going to put Benedicts in there. And then we're going to put, this is milk. And so I'm going to put Benedict's solution in the milk. Now you might remember from your freshman year, this test has to be heated up. So I've got some hot water here. And we're going to pour hot water in there. And we're going to let it sit. All right, and we're going to come back to that in a minute or so. All right, meanwhile, here's another test that we can test for the presence of polysaccharides. And for this one, we use a chemical, and remember this, because we're going to use it again and again and again in the future. This is called IKI, iodine, potassium iodate. And look what it does. If we put it in water, move that out of the way. If we put that in water, we know that water is not a carbohydrate, so it just stays yellow. If we put it in a known polysaccharide, watch what it does. Wee-ha! Look at that. And then let's put it into something that we don't know what it's going to do. All right? Milk. Let's put a squirt of iodine in there, and look at that. It's a negative test because it stays yellow. Okay? So milk does not have starch in it. Let's go back and look at this one. Just as we suspected, water's a negative. There's your monosaccharide, turns orange. And look at milk. All right? That's because milk is a negative. That's because milk has lactose. And lactose is a disaccharide, and so it won't test for Benedict's reagent. So that's a different test. We'd have to do something else. So now the last thing I want to show you, come on around here. I want to show you the energy that's in sugar. So the first thing is, over here at my oven, at the stovetop, I've got a glass dish, and I put a little foil dish, and I'm going to use a mortar and pestle, and I've got a chemical in there called sodium chlorate. And what that does is it provides us with a little bit of extra oxygen atoms to get this chemical reaction going. And then I'm going to put some sugar in here, just a teaspoon of sugar, because I want to show you the energy that is in sugar, that is in carbohydrates. You know that things like this, wood, burns. You know that it has a lot of energy in it. But what about other carbohydrates? So let's do this. So I'm going to grind up this sugar a little bit. And I'm going to pour it into this little pan here. All right, there we go. And then I'm going to take sulfuric acid. Now, sulfuric acid will help to rip apart the carbon bonds. It'll just like if you put sulfuric acid on your clothes, it'll start to shred your clothes. Well, here it is. We're going to shred the carbon atoms and shred the molecules apart. And then watch what happens. All right, here we go. A teaspoon of sugar, and look at all of the energy that came out as those bonds were being broken. Welcome to the energy of carbohydrates. And look what's left. Carbon.